Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Chaos Construct-to-N by Mello Robinson. I see what you did there. Anyways, here are the rules. We have chaos construction rules where we need to divide the grid into 9 orthogonally connected cells or connected regions, each consisting of 9 cells. And we need to fill every cell with a digit 1 through 9 without repeats in any row, column, or region, designated or not designated, any 9-cell region that we come up with. So this would be, for an example, well, no, not technically. This would be a valid example of an orthogonally connected region. And what it means to be orthogonally connected for the region is you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So for example, to get from this cell to this cell, you just go this way to connect. What you cannot have is something like this, because to get from this cell to any other cell in the region, you either have to go through a corner or go outside of the region, which is not allowed. Similarly here, even though these two can connect to each other by going through an edge while staying within the region, they cannot go to any other cell in the region by going through an edge, all while staying within the region, right? So that is how orthogonally connected regions work. We also have an up to n sums, where a clue outside the row or column n indicates the sum of all digits up to the cell that contains the digit n. And note, the digit n itself is not included in the sum. A question mark stands for any number greater than 0. So any of these numbers have to be greater than 0. This 23 says that until you reach the 2, all the digits before that must add up to 23. So you could have, for example, a 2 here, and then like 9, 6, and 8 here. And this would be valid because the digits before you reach 2 add up to 23. So that's an example of how up to n sums work. And additionally, all digits up to the digit n are in the same region, and the digit n is in a different region. So say we had this example, then these would be in one region, and this would have to be in another region here. And that's all the restrictions there. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. To add up to 30, it requires at least 4 digits to add up to 30, right? 6, 7, 8, 9 is the maximum you can have. So you need at least 4 digits. They are all in the same row or column here. To add up to 21 requires 3 digits. We don't know which one, so it must be at least 3 digits here. This must be at least 3 digits here. This has to have at least 3 digits in the 24. To add up to 23 must be at least 3 digits. Okay. That is interesting. 19 requires at least 3 digits. So these could be the same region, right? We don't know. Question mark stands for any number greater than 0. Obviously, if you had in row 1 a 1 in the very beginning, then that would not be possible. So this can't be 1 here. So 1 cannot be in column 1, cannot be here, because it must... So 1 in column 1 has to be one of these 4. 2 in column 2 has to be one of these 6. 4 in column 4 cannot be here because this must be non-zero. It's greater than 0. So it has to have something here. So 4 could be one of these 5 because of this 21. 8 again can't be here, so 8 has to be one of these 5. 1 can't be here, and 1 can't be here, so 1 is one of these 7. 3 can't be here, so 3 has to be one of these digits. 4 again cannot be here because 3 digits cannot add... Less than 3 digits can't add up to 24. So it's one of those. 5 cannot be here, and it can't be one of these 3, so 5 has to be one of these. 6 could be any of these. 7 could be any of these. 8 has to be... Cannot be here. Can't be here. Can't be here, so 8 has to be one of these sets. And 9 can't be here. It could be here. Okay. So what happens if it's this way then? That doesn't work. These cannot be the same region. Because if these were the same region, this would add up to 24, and this would oh, well, this could be 2. No, it can't be 2. Okay, maybe they can be the same region. Interesting. Oh. Well, So what did these question marks mean? That means there's at least one digit here. So if these are not part of the light region, they have to be part of the green region. Right? Because they can't go out anywhere else. So let's mark the boundary for the entire grid. What does that mean? So again, if they're not part of the light region, they're part of the green region. Okay, that seems fine. What if they are part of the light region? That means, so this is either light or green. Right? It could be technically both, but that's unlikely. Oh, yeah, what happens if they're both? Then you could have a 9 here. So can this ever add up to what it's saying here, right? I think the answer to that is no. So you have 9 here. This would be 7 and 8. So if these are the same region, these have to be part of that region. So this would be 9, guaranteed. You'd have, what? 9 here, 7 and 8 here. So that's 24 there. So 23 minus 9 is 14. So that is possible. 14 would be 3, 5, and 6, which would force this to be 1, 2, and 4 here. So you'd have 7, 8, 7, 8, and 9. Or it could be 7, 9, 7, 9, 8. And then this could be 4, 5, 6, 1, 2, 3. That seems like it does kind of work. But then okay, so then the problem though is 1 becomes one of these 3 digits. And then all of these would have to be 30 and be in the same region, which means this would be all in the same region. So this has to be different regions here. So this must be a 2 here. So this is 2, which eliminates 2 in the rest of the column. That means this green has to go at least to here, so this can't be 4. Because 24 minus 2 is 22. This is either part of light or it's part of green. We have 1, 2, 3 here. I guess it could be the same. How would that work? Maybe 9 here. So 30 minus 9 is 21. So this would be 21 plus 24. So it's possible. So it's possible that this is the same region. We just know this is... Okay, so this has to be 6, 8, and 9 here. Add up to 23. That eliminates 6, 8, 9 in the rest of column 2. So we have 1, 3, 4, 5, 7 as possibilities. Let's see. Yeah, so 9 could be here. And then this would be 1. And then that would add up to 45 there as a region. Oh, hold up. Okay, for these, that means the 4 has to be between, essentially, these digits, right? It has to be, it has to all be the same region. Okay. And it can't, if this is the same region here, these are 15 cells, which can't form one full region, or it can't be one region by itself, and it can't be form 2 full regions. So this cannot be the same region as this. Therefore, this must be the same region as this. So it must go this way, because if it doesn't, again, this is going to all the way to the 4. This is going all the way to the 4. So the 4 has to be somewhere in between these regions, right? Well, this is going to be part of... It can't be... You can't have 4 here, because, again, this is going till 4, right? So because you can't have 4 here, that means this can't be 4 here as another digit. It has to be either part of this region here or part of this region. And it can't be part of this region because that would force this 15 block to not be able to... You could form one region, but then 6 cells are left out from a region. So therefore it has to go this way. This is 7 cells, so that means you cannot have this be green. Also, this light has to form a full region of 9. It has to contain all of these then. So then these are all light. So we've got something similar here, right? Orange is either part of blue or it's part of this region. Um, Same with this, actually. We have either it's here, here. So these could be part of the same region. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's part of blue. This yellow is part of blue or red. We don't know which. It cannot connect this way because then this is 6 by itself, which isn't a region. Cannot go this way, same problem. So it has to either connect this way or it connects this way. It cannot go this way. Well, it could if this is by a region by itself. So yellow either goes this way or it goes this way and connects to red or blue. Because if it doesn't, if it tries to go this way or this way, these are form a region which is not connected. This has to be 3 digits then. So this cannot contain 4. It's either 579 or 678. So we know there's this guaranteed 7 here. Because, again, it must be part, because of row 8, it has to be part of either this region or this region. Actually, that's not true. That's not true. It could be a separate region by itself. With an 8 in it. That's possible. Okay, never mind. This is still correct, though. That means the remaining digits, so this cannot be 1. This has to be a 1 here. Because it forms a region, and then the N is a different region. So that means 1 cannot be here. These can't be 4. Because 4 has to be one of these two. We need a 4 somewhere in the green region then. Huh. Remaining digits in the light region. We have 1 cannot be here. 1 could potentially be here. So we have 1, 2, 3, 4, 5, 7. And this can't be 1. This can't be... oh. This cannot be 3. These can't be 3. This has to be a 3 here because that's the end of that. So again, 1, 2, 3, 4, 5, 7. 3 cannot be here or here. This can't be 1. This is 7, so this cannot be the same region as this. And this cannot contain a 1. So that means the 1 has to be here. And it can't be green. It's part of another region. Interesting. Okay, let's make this medium. And we'll make this a different one, green. So this is 1. It cannot be 1 here. This means this has to be 6, 7, 8, 9. Which eliminates 6, 7, 8, 9 in the rest of the column. So no 7, therefore this must be 2, 3, 4, 5. Cannot be 2 or 3 because of the 2, 3 in the region. So this is 4, 5, which means 2 or 3 has to be here. So this cannot be 2 or 3 in the rest of the light region. So red is done there. This is a separate region because medium gray already has a 1. This is 3. This has to be all the same region till the 1 because it's a question mark. So then we don't have we have a boundary there. We don't know if this goes down here. So 4 is one of these two. So we know this is 1, and we also know there's a 7 there. Remaining digits in... oh, this can't be 4. Because 4, it has to be until 4. So this is 5. No 4 or 5 here. This can't be 5. This can't be 4. This can't be 5. This becomes a 2, 3, 4 triplet, which eliminates 2, 3, 4 in the rest of the region. So this is 1, 5, 7. Obviously, this can't be 1. To add up to 24, we have 7 here. Remaining digits are 6, 7, and 8 possible. So 7, I think it has to be 2 digits here. Because if you don't have 2 digits, try to have 3 digits. 6, 7, and 8 with 7. That's minimum 28, which is too big. So that has to be 2 digits. So this has to be a border here, and this must be a 4 here. So none of these can be 4, which means we need access to a 4. But this can't be, this is up until 4. Well, 4 can't be here. It could extend here, potentially. We need access to a 4 as the gray. This is another region. If we go 1 here, then we need to have a 4 here. If we go here, if we blocked here, that means it must go 1, 2 here to be 4, 1, 2 here to be 4, or 1, 2 here to be 4. So those are all possibilities. Can you add up to 21 without 4? I guess 5, 7, 8, and 9, and then you have 4, 2 here. This has to be, this has to be 7, and this is 8, 9 as a pair. So no 6, 7, this is 8, 9 as a pair, which eliminates 8 and 9 in the rest of the region. So this is 6 or 7 here. Green is a different region than red, guaranteed. Red cannot be part of yellow. If red is part of yellow, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. But then that adds up to way too much. Oh, yellow can't be part of blue either. Because you have 21 here and 19 here. That's 40 plus 3 digits, which would be 1, 2, 3 at minimum. So that's 46 as a region, which is too large. Yellow has to be its own region. So red is blocked here. Green has to get out somewhere. I guess it could be part of yellow, technically. So 5 cannot be here, because 5 would be part of... this is up until 5. This can't be 5 because of the 1, 5, 7 triplet, so this must be green. Interesting. That means this cannot go... If we try to go gray here, where's the 4 you're going to access? It can't access here, it can't access here, it can't access here. So it would be stuck. So this cannot be gray, therefore this must be the 4. So this must be 4, and it must be part of green then. So that's part of green. So this is boundary. The gray has to go out and then another digit. So this is 4, which means this is all yellow. So this is yellow. We have, I guess part of this could be part of yellow too. We have a 2 and a 5 here. That adds up to 7. We're guaranteed a 2 and a 5 here. This is a boundary. This is a different set than this. So gray has to go either, medium has to go 1 there or 1 there. We don't know. Okay. I mean, technically, this can't be the same. No, this can't be the same. So one of these two is 5. This can't be 4. So this is 21. That's 4. That's 25. So this must be 20. Well, to be 20, it's 1 and 3 here. You have to have 7 and 9 here. So that's 7. This is 9. This is 8. That leaves these digits. So this could be 8. This has to be 8 here. There's no other because otherwise this doesn't fulfill the criteria of going all the way here and going all the way here to being the same region. So, because this would then have to be the same region as this or this one of the two, and it can't be either. So this is blue. 1, 2, 3, 4, 5, 6, 7. This must be part of blue because it's blocked in. This then must be part of yellow because it can't be part of blue, and there's blue. The only options are blue and yellow as regions. So this could be blue or yellow. We don't know. This is red going this way, so it's red, red. Therefore, 1, 2, 3, 4. This could be red or yellow. We don't know which. We have 8 here. The remaining digits are 2, 5, and 6 in column. So therefore, where's 9? 9 cannot be here because it must be the sum up to 9 here. This obviously can't be 8 anymore. This can't be 7 because of the 6, 7, 8, 9 quadruplet in the region. This can't be 1 or 5 or 6, 7, 8, 9. So this is 2, 3, 4 here. This is 2, 5, 6, 8. The remaining digits are 1, 3, 4, 7, 9. This can't be 4. This can't be 9. So one of these, so the yellow 9 has to be one of these two. So it's going to be a yellow 9 here. Can this form a region of green by itself? No, so it has to go out to here, which means that's not a 5. So this is green, this is a 5. And this is boundary, this is boundary. So this is 3 digits adding up to 21. And we have boundary here and boundary here. If we try to connect this to here, that's too big. If we try to connect it to here, that's also too big as a region. So this must be the 8, and it is the boundary there. And then this must be blue. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this cannot be blue, that's yellow. So this is the 9 here. Because it must be up to 9. Blue is done. So this is done as a region. That means orange has to go this way. Yeah, I mean, this must be part of orange. And this must be 8. We have 21. We can't have 4 or 5, so no 4, 8, 9, no 5, 7, 9. It's 6, 7, 8 adding up to 21. So this is 6, 7, 8 here. This can't be 6. This can't be 7 because of the sum 2. This can't be 7. This is 3 now. That eliminates 3 in the rest of the row. Sorry, column. It also has a 2, 9 pair in the green. We have to go out somewhere. Well, do we? Yes, because we have at least 9 digits here. Yellow's a separate region. So this would be at most 1, 2, 3 greens, 4, 5, 6, 7, 8. So it has to go out. So this is green here. So this is boundary here. This is probably part of pink. Okay, this is boundary too. Where is 8 in the blue region? Cannot be here, cannot be here. So it must be here. So this is 8. This adds up to 19. Oh, this is a boundary here too. So this must be 1, 2, 3, 4, 5, 6, 7, 8. We don't, so this has to be orange here too, because we have 8 cells already for the dark region. And it can be at most 9 here. If it tries to cut off this, then this doesn't have a region, so that's not allowed. So these are guaranteed orange. This is orange or dark. We don't know which. So this is a boundary. So this is done. 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 This is not done, not done, not done. Okay, so this is, well, no, this one's done. So this one's done, and this one is done. This one's done. 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 This is done. 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 Okay, so this must be to 9. So this is 9. Remaining digits in orange are 1 through 5. This adds up to 19. This we don't know. This has to be, so we can't have 1 through 4 or 9, so this is 5, 6, 7, 8. This can't be 6, though. Because this, okay, where, If we try to have red, red, that is possible. One, two, three, four, five, six, seven, 8. Is that actually possible? I don't think so. So we can't close both. We can't close red off. We can't complete red here because that would close green off. And then this would be how many cells? 4, 8, 12 plus 7. That's 19 cells for 2 regions guaranteed, which is not allowed. So this cannot be red, red, red. So this can't be 6. We need a 6 then to be the last digit. So this is 6 here. It cannot be yellow because we have a 2, 5, 6 triplet in yellow. So this has to be green. So this must be red and red there. And this is possible. So this is done. Remaining digits in column 3. We have 2, 3, 4, and 9. This can't be 9. 2, 3, 4, and 9. This is not the same region as this. So this must be a different region. It has to be 7 here. Which means 7 cannot be in the rest of the column. So this is a boundary. And it could be green. So this is 1, 2, 3, 4, 5, 6, 7. We have 8 and 9. Because red can't be here. Because that would block off this from another region. So then this is not yellow, but this could be yellow or green. We don't know which. So this is done. So we have 1, 4, 5 as a triplet, which eliminates 1, 4, 5 in the rest of the red region. So this cannot be 4 or 9 because of the 6, 7, 8, 9. So this is a 2, 3 pair, which eliminates 2 and 3 in the rest of the column. So this can't be 2 or 3. This is 4. This can't be 2. This is 9, which forces this to be 2. Well, we already have a 4 in the green region, so this can't be green. This is yellow. So that means this is boundary, boundary, boundary. We have 1, 2, 3, 4, 5, 6, 7. So the yellow's all done. So then this cannot be 7 or 4. It's a 1, 3 pair, which eliminates 1 and 3 in the rest of the row. This can't be 1 or 3. This is 2, which makes this 3. This can't be 2 then, because of the 2 in the row. This can't be 1. No, 8 here, because of the 8 there. This can't be 9, because of 9 in the row. I Pink sort of has to... we need two grays, two mediums. So one of these is going to be a 4. We could have, again, there's eight dark cells, so dark could go 1 here. Pink could go all the way around here, so this is all possibly pink. I think that forces this to be pink here, right? Green can go, so we need 2 more greens. 1, 2, 3, 4, 5, 6, 7. Right, 2 more greens, so it could be 2 green here, 2 green here, but not here. This can't, orange can only be 1 more, so orange could be 1 more each way. Pink, again, cannot close off green, so pink has to go this way then, which means this cannot be green. This can't be orange. So pink has to go this way because there's no other region for this cell, because green can only reach to here or here. So therefore we are done with green region, which must be 5, 7, or 8. This can't be 5 because of 5 in the column. This 7 eliminates 7 here. So this is 8, which makes this 5. 8 eliminates 8 here, so it's 6. This can't be 5 or 8, it's 7. 5 eliminates 5 here. Cannot be 6 either because of 6 in the row, so this is 2, which makes this 5, which makes that 6. 6 eliminates 6 here, so it's 7. This can't be 6 or 7. It's 9. This can't be 7 or 9. It's 8. This can't be 5 anymore. Okay. Remaining digits in row 9 are 4 and 5. 4 is one of those 2. This can't be 3 because of 3 in the row. This can't be 2, 4, 5 because 2, 4, 5 in the row. What are the remaining digits in row 4? We have 1, 3, 6, and 7. Okay. Remaining digits in row 7, are 1 and 3. Remaining digits in row... Okay, this 5 eliminates 5 here. Remaining digits in row 6 are 1 through 4 and 9. 4 obviously cannot be in the pink region. Okay. We need a 9 for the blue region, and it cannot be here, it cannot be here or here, so it must be here. So this is 9, which eliminates 9 in the rest of the row. So that means these add up to 10, because 19 minus 9 is 10. Well, you could have 1, 4, 5, or it's can't be 3 and 4. It could be 3 and 5 and 2. So those are the possibilities. Remaining digits in row 8 are 1, 2, so 3 can't be here. Where is 3 in the blue region? It has to be here. So this is 3, which can't be with 4 and 3 to add up to 10. It has to be with 5 and 2. That means this 5 eliminates 5 here. This is 4, which eliminates 4 here. So this is 1, which eliminates 1 and 4 here. So that's 5. This 1 eliminates 1 in the rest of this row. So this can't be 1. This is a 2, 3 pair, which eliminates 1, 2, and 3 in the rest of the row. So this is 4. This 2, 3 pair eliminates 2 and 3 in the rest of the pink region. So this is 1. This can't be 3 because of the 2, 3 pair in the region. This is 4, which eliminates 4 here. Remaining digits in the blue region are 1, 4, 6, 7. And this can't be 4. This can't be 1. This can't be 4 because one of these must be 4 for the medium gray. This can't be 4 or 7. Okay. What else do we have? This is 2, 3. This is blocked there. This can't be 1 anymore because of 1 in the column. This can't be 3. Remaining digits in column 8. We have 1, 4, 6, 7. This can't be 1, no 7. So we have a guaranteed 1, 4, 6, 7 in the dark region. That eliminates 1, 4, 6, 7 in the rest of the region. So this must be 2, 3, 5, 8, 9. 2, 3, 5, 8, 9. No 8 or 9 there because of 8 and 9 in the column. No 2, 5 here because of 2, 5 in the column. No 8, 5 here because of 8 and 5 in the column. No 9 here because of 9 in the column. Okay, so I think all the up to n sums are done. This is done. We have, this is the same region, and then this is a different region 1. This is the same region, this is a different region 1. This is the same region, this is different region 3. This adds up to 24. 7 plus 8 plus 9, and that's a different region 4. This is the same region, that's a different region 5. This adds up to 21, different region 5. Same region 6, different region 6. Same region, different region 7. Same region, different region 8. Same region, different region 8. Same region, different region 9. This adds up to 30, and then we have 1. This adds up to 23, and then we have a 2 with different region. Same region, different region 4. This adds up to 21, 6, 7, and 8 in different region 4. Same region, different region 8. This adds up to 19 plus different region 8 here. And I think, yeah, that's all the up to n sums. So now we just have to do sort of normal Sudoku then. This can't be 4, this can't be 4, this can't be 4. Where's the 4 in the blue region? It must be there. We have to have a 4 and a 6 in the gray region. So 6 has to be one of those two, because 4 has to be one of these two. Well, that 6 eliminates 6 here, so this is 1, which eliminates 1 here, so it's 3, which eliminates 3 here, so it's 1. So these cannot be 1 anymore. This becomes a 6, 7, 6, 7 pair in column 1, which eliminates 6 and 7 in the rest of the column. So this must be 1, 2, 3, or 5 here. Okay. Remaining digits. Okay, 3 eliminates 3 here. Remaining digits in column 5 are 6, 8, 9. Interesting. Remaining, okay, 1 eliminates 1 here. Okay, we also have a 1 in the pink region, so we knew that. We have a 6, 7 pair in column 6, which eliminates 6, 7 in the rest of column 6. The remaining digits now are 2, 3, 4, and 9. Obviously, this can't be 3 because of 3 in the row. And remaining digits in column 8. Sorry, 7. They have to be 2, 3, 5, 6, 7, 8. This can't be 7, this can't be 3. Okay. That seems fine. Okay. If this were orange, it would be 3. Because it can't be 6 or 7. If this were orange, hold up, we have 1, 2, 3, 4, 5, 6, 7 orange. So this must be orange here, and this must be orange here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Okay, so then this is done as a region, as for orange. So again, this can't be 6 or 7 because of the 6, 7 pair in the region. So this must be 3, which means this can't be 3. This is 1, which means this can't be 1 or 3. So this becomes a 2, 5 pair, which eliminates 2 and 5 in the rest of the column. So this can't be 2 or 5 here. This is 3, which eliminates 3 in the rest of the row. That's 3 in the corner. We celebrate because we know we're close to solving this. This can't be 3 because of the 3 in the column. So this is 2, that's 3. That eliminates 2 from the rest of the column. So this can't be 2. This can't be 3 here because of the 3 in the column. This can't be 3 here because 3 in the column. Okay. This can't be 1 because of 1 in the row. Okay, we have all the 3s? We do. This is the last 3. So this is 3. 1s. We don't have all the 1s. 7 eliminates 7 here. Okay. Let's see if we can distinguish 6 and 7's pairs. We're going to label this A and this B. So then this is A, this is B, this is B. So we have A here, B here. We don't know... Oh, this is... Okay, so... Right, A is there, so this is B and B. This B being here makes that A, which makes this a B, so that makes this A. So we need another B here. This is B, so one of these is A. Pink has to go here. Because dark already has 6, 7 in these cells. Well, where's the other 6, 7 in column 7? It has to be one of these two. So either it connects that way, which it can't, because it has to go pink, has to go medium, medium. Oh, this can't be medium, medium here. Black blocks off pink as a whole. So this cannot be medium, medium. Therefore, this is pink, pink. This is medium, medium. So that's done as a region. And again, pink has to be one of these. So it's 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And this must be 9. So this is not dark, which means this is dark. So that's done as a region. Again, this has to be 6 and 4 for medium, which means this can't be 6. This can't be 6. This has to be, so this can't be 6 or 7's guaranteed here, so this can't be 6 here. This becomes a 5, 8 pair, which eliminates 5 and 8 in the rest of the dark region. This is not 8, this is 9. That 9 eliminates 9 here, so this is 2. Therefore, this can't be 2, this is 4, this is 2. No 9 here. 4 eliminates 4 here. This is the other 6, 7 in the dark region, so this cannot be 6, 7 here. This 4 eliminates 4 here, so this is 1, which makes this 4. This can't be 2 or 4, it's 9. This can't be 6 or 9, it's 8. Therefore, this must be a 6 or 7 here, and is the A 6, 7. 1 eliminates 1 here, so this is 5, which makes this 7, which makes that 1. 7 eliminates 7 here, so all the B's are 6. So the B's are 6, and the A's are A. Or, sorry, 7. A's are 7. This can't be... This 2 eliminates 2 here, so this is 5, which makes this 2. 5 eliminates 5 here, so it's 8, which makes this 5. 6 eliminates 6 here, so it's 8. This can't be 6 or 8. It's 9. This can't be 8 or 9. It's 6. And that's a solution. Yeah, fairly straightforward. Once I started understanding how the rule set really interacted, it made it fairly straightforward, I would say, to understand how these worked, right? Pretty cool. Pretty cool. I mean, I love chaos construction rule sets. So this was right down my alley, and I really enjoyed it. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.